Electric charge, also known as the quantity of electricity, is a crucial element of everyday matter. Everything around us, from objects to atoms, is composed of molecules made up of protons, neutrons, and electrons, all of which contain electric charge. Electric charge has substance-like properties, meaning that it cannot be destroyed, but can only be moved from one place to another. When there is a flow of electric charge, it is referred to as electric current. Understanding the structure of atoms helps us comprehend electric charge. An atom consists of a central nucleus, which contains protons and neutrons, surrounded by electrons, revolving in different orbits. Protons bear a positive charge, while neutrons have no charge. Thus, the nucleus of an atom carries a positive charge. On the other hand, electrons are negatively charged particles with the same magnitude of charge as the positive charge on a proton. Normally, the number of electrons in an atom is equal to the number of protons, resulting in a neutral atom. In this state, the negative charge of electrons cancels out the positive charge of protons, making the overall charge of the atom neutral. However, when a body has an excess or deficiency of electrons from the normal, it becomes charged or creates an electric field. There are two types of charges: positive and negative charges. In general, objects contain an equal amount of positive and negative charges, making them electrically neutral. When an object has an equal number of positive and negative charges, the net charge on the object is zero. Atoms always have a net charge of zero, but ions can have either a positive or negative charge, depending on the imbalance of protons and electrons. As electrons are more mobile than protons, we can transfer electrons to a neutral object to give it a net negative charge. In doing so, the object from which we transferred the electrons becomes positively charged. It's important to note that the total electric charge of the two bodies together remains unchanged. This principle is known as the conservation of charge. We cannot create or destroy electric charge. We can only transfer charges, electrons, from one object to another to change the net charge of the objects. The ancient Greeks discovered that electric charge could be transferred between two objects by rubbing them together. When plastic and fur are rubbed together, electrons from the fur are transferred onto the plastic, leaving the fur positively charged and the plastic negatively charged. This simple act demonstrates the transfer of electric charge.
When glass and silk are rubbed together, the glass becomes positively charged. On the other hand,
when plastic is rubbed with fur, it becomes negatively charged.
This happens because
when materials are rubbed together, electrons can be transferred
from one material to another.
For example, when we comb dry hair, the comb becomes charged and can attract small pieces of paper.
This is due to the transfer
of electrons from our hair to the comb. Furthermore, when a glass
rod is rubbed with a silk cloth or an ebonite rod is rubbed
with woolen material, the glass rod acquires a positive charge, while the ebonite rod acquires a negative charge. Although the charges on electrons are tightly bound to atoms and insulators,
they can still move
slightly within the atom, which is called polarization. If a plastic comb is
rubbed on fur or dry hair, electrons are transferred from the hair to the comb,
resulting in a negative charge on the comb. When the charged comb is brought close to a neutral insulator, like dry paper,
the negatively charged
electrons in the atoms of the paper move away slightly, leaving the protons without an electron closer to the comb. As opposite charges attract, the positive charges in the paper are closer to the comb, causing the piece of paper to be attracted to the comb. This phenomenon is also used to remove soot and ashes from industrial chimneys. It is important to note that a charged comb whether negatively,
or positively charged.
attracts a piece of paper. Similarly, a glass rod and an ebonite rod,
Attract each other,
while two glass rods
or two ebonite rods.
will repel each other. The unit of charge used.
In this context is called coulomb, to illustrate the flow of charge.
Let's consider two metallic spheres, A and B.
Placed on insulated stands.
If sphere A is positively charged and sphere B is negatively charged, and these spheres are
Connected by a metallic wire.
the flow of electrons will occur from sphere B at lower potential to sphere A at higher potential. This flow of electrons will continue until the potential of both spheres becomes equal. This demonstrates that the flow of charge, specifically electrons, between 2 points occurs as long as there is a potential difference between them.